Hello, everyone, and welcome to Lesson 3 in 2019-2020 for solving for algebra. In this lesson, we'll be talking about how to solve algebraic equations. So that is finding out what the value of a variable, so finding out what the unknown number is. We've already looked at the terms and all of the different symbols and terminology that we see in algebraic expressions and equations. And then we also looked at input and output tables in the last lesson. Now, in this lesson, we're going to be reviewing a little bit, as well as adding on. We have looked at solving for algebraic equations before, even if you didn't know it. When we were looking at area, perimeter, and volume, we were trying to find the unknown side or the unknown value, and we did the opposite or inverse operation to try and find that, whether it's addition or subtraction or multiplication or division. So to keep this video as short as possible, so it's not dragging on for half an hour or more, I'm going to do two things. One, I'm going to read through the steps very quickly so that you guys have the ability to watch this again and again to get the steps and at any speed that you want. And then we're going to go through some examples of the materials that I have provided so that you can see how they're put into effect and how we can make them even more effective. So starting off, solving algebraic equations. At last, the moment we've all been waiting for. Let's solve some algebraic equations. The goal when we are solving any algebraic equation is to isolate the variable. Isolating the variable means we get it all alone on one side of the equation. And remember that variable is the letter of the unknown number that we are looking for. Remember, equations must always balance like a scale or a teeter-totter. So everything on one side of the equation or the equal sign must equal the other side. And that is the key for being able to find the unknown number. So starting off, just going through the steps, and then we'll go through the example with the steps again. First thing you do, split the equation down the middle. When I say the middle, I mean down the equation. Wherever that equal sign is, that is the middle. Everything on the left side of that equation, when all is said and done, will equal everything on the right side of the equation. Step number 2, if there are any numbers that can be combined on either side of the equals side, do it. So in the case of if you have two variables, if you have 2x plus 5x equals 28, or 27, you can add the 5 and the 2x, and that would give you 7x. So that is the simplifying of the algebraic expression. And we'll see more examples of that as we go on, because that can happen even with non-variables, with those complete numbers. Next, locate the term with the variable in the equation. So you want to find the term with the variable in it. Identify if something is being added or subtracted to the term with the variable, and if there is, perform the opposite operation to remove it. So you want to do the adding and subtracting first, and then multiplying or dividing. We're going the opposite of BEDMAS because we're trying to isolate the variable as much as possible first. So step 4, add or subtract if you can. Number 5, remember, whatever you do to one side of the equation, you must do to the other side to restore balance. If you're subtracting 5 from the left side, you have to subtract 5 from the left side, or right side. Once that's done, bring the rest down and reset the equation. So write the equation out with everything that you have left. Now look at the term that has the variable in it and ask yourself, what is being done to this variable? Is it being multiplied? Is it being divided? And whatever you identify as happening to it, do the opposite. If your variable should stand alone after this step. So once you've multiplied or divided, it should be alone after this step. Whatever you do, again, to one side of the equation, you have to do to the other side to restore that balance. Finally, check your work by substituting your answer back into the original equation. Whatever final answer you're given, you can always check to see if it's correct by putting it right back into the original equation. If you do both sides correctly, they should equal each other after that. Now, obviously, the best way to learn this skill is by doing it. So let's practice doing that. I will plug in our camera here. There we go. Sorry. See what that does with that override. The other camera? No, it won't. So what we're going to do is we're going to open that. There we are. Okay, let's get every single chord in the town out of the way. There we go. Let's set this a little more. There we go. See as much as we can there. Perfect. Let's get that actually clear. There we go. Okay, so the first example we have is 2x plus 5 equals 50 minus 5. And let's just go through the steps. So the first step, looking at the equations, if you have the notes in front of you as well, you split the equation down the middle. That is step number 1. We split it down where that equal sign is. So at the end, everything that is on this side will equal everything that is on this side. If there are any numbers that, or step number 2, if there are any numbers that can be combined on either side of the equal sign, do it. Again, this is called simplifying the equation. Now, there's nothing we can simplify on this side. 2x is good, and there's no other constants here that would be the 5. But there are 2 constants on this side, so we can simplify this side. So 50 minus 5 gives us 45. Now, I said bring everything down, so now we have to reset the equation. 50 minus 5 gives us 45. And now our equation is 2x plus 5 equals 45. Still means the same thing, it's just simplified. Number 3, locate the term with the variable in it. Now I am missing some of my... There we go. So we want to locate the variable with the term in it, or the term with the variable in it. This is the variable, remember that, because that is our unknown number. We don't know what x equals yet. So that is step number 3, locate the term with the variable in the equation. Number 4, identify if something is being added or subtracted to the term with the variable. If there is, perform the opposite operation to remove it. So we are looking, is something being added to this term? Remember, a term is anything that is isolated or separated by those operations. So this whole 2x is a term, and it is being a 5 is being added to it. So we want to do the opposite operation to try and get x by itself. So the opposite of plus 5 is minus 5. Those cancel out because plus 5 and minus 5 are opposites. But whatever we do to one side, we have to do to the other to maintain that balance. So we have to subtract 5 as well. So 45 minus 5 gives us 40. And now we bring down what's left. The rest of our equation is 2x equals 40. So that's step 4. We're already halfway done. The next step, step 5. Step 5 was whatever you do to one side, you do to the other. Step 6 is now we're looking at the variable that's left. We are trying to identify what is happening to it. Is it being multiplied or divided? Remember, this number in the front is called the coefficient. And if it's right next to a variable, that means that is multiplying the variable. So 2 times x is equal to 40. And we want to do the opposite of multiplication. Grab another pen. So the opposite of multiplication is division. So we divide by 2. Whatever we do to one side, we want to do to the other. So we divide the other side by 2. All of a sudden, because 2 times x is the opposite of divided by 2, we can cross those out. And x is equal to 40 divided by 2. All that is left is 20, because 40 divided by 2 is 20. So our answer is x is equal to 20. Now, the final step is check your work by substituting it in and making sure it works. So if we go 2 times 20 plus 5, that gives us, well, 2 times 20, because I'm substituting the 20 in where that x is, that gives us 40 plus 5 equals 45. And 50 minus 5 gives us 45. So the two sides are equal. So that is going through literally every step. Now, that is the hardest I will ask you guys to complete as far as a multi-step one. But yeah, it's a great starting example because it goes through every single step. Let's look at another one. The one on the next page is m, and I'll do 3 more, and then we'll go through the others in class. I will still give you the answer keys for it so that you guys can see all of the steps, but we'll go from there. So remember, the first thing that we want to do is see if there's anything that we can simplify on either side. There's nothing to simplify on this side, but there's 2 constants here. So we can combine them, and our new equation is m over 6 is equal to 3 plus 4, which is 7. Now we see we identify where the variable is, and we have found the term with the variable in it, right here. Well, the whole thing is in the term because it's being divided. The m is the term, but what is happening to the term? It is not being added or subtracted to anything, but it is being divided. What's the opposite of division? Multiplication. So we multiply by 6, both sides. That cancels. 7 times 6 gives us 42. Our answer is 42. Now we can put it into the original equation to see if it works. 42 divided by 6 gives us 7, and 3 plus 4 gives us 7. The 2 sides equal, we have found our answer. Next. X divided by 3 minus 2 equals 5. First thing we do, we look if there's anything we can combine together. That's simplification, simplifying it. Nothing's popping out. There are no constants, multiple constants on this side or this side. This is as simple as we can get this equation. So the next thing we want to do is identify the term that this is in, or the variable is in, sorry. So we've identified where it is, and now we want to see if anything is being added or subtracted to it. It is, in fact, being subtracted by 2, so we want to add 2. They cancel out. We add 2 to the right side because we want to balance. And all of a sudden, we have x over 3 is equal to 7. Now we identify if it is being multiplied or divided. It is being divided, so we want to do the opposite. X divided by 3 times by 3. Both sides, because we want to keep it even. 7 times 3 is 21. Oops, sorry. X is equal to 21. We put that into our original equation. 21 divided by 3 is 7, minus 2 gives us 5. The 2 sides are balanced. Now, these can be simpler. Everything that we've seen so far is mostly 2-step equations, but they can be as simple as your next one. F plus 5.5 equals 11.2. We simply have to see if anything simplifies. It doesn't. We identify if something is being added or subtracted, and it is. 5.5 decimal, or 5.5 is being added to the unknown variable. And so we simply subtract 5.5 from each side to cancel out. F is already isolated, so we know whatever our answer is here is going to be our final answer, and that is 5.7. We can check it. Does 5.5 or 5 and 5 tenths plus 5 and 7 tenths equal 11 and 2 tenths? It does. All right, I would like to do one more just on the back page. Something as simple as this. So 8D is equal to 64. We see if there's any adding or subtracting going on. There's no simplification going on, so we can skip straight to multiplying and dividing. We recognize that because this number is in front of the variable, it is 8 multiplied by d. The opposite of that is divide by 8. We divide both sides by 8. Cancel, cancel. D is equal to 8. That is it. That is solving the equations. These are through many of the other units that we have looked at. It is a very similar set of equations and set of rules that we have followed before. If you guys have any questions at all, this week is a perfect week. We're going to be practicing. We're going to be putting into more practice next week, and then we'll be looking at balancing equations the week after that. So if you guys have